Hello, in this video we're going to be looking at circumpolar stars. Firstly, let's remind ourselves about the stars in the night sky. The stars appear to move through the night sky, rising in the east and setting in the west. But the stars themselves are not actually moving. This effect is caused by the Earth rotating on its axis. Now, when you look at the stars that are moving in the night sky, and if you face north, you'll notice that all of the stars seem to rotate around one point in the night sky. And that point is here, the star Polaris. Well, to be more precise, you'll notice that even Polaris rotates a bit, as it's not perfectly on the point through which the Earth's axis would pass. That point is known as the North Celestial Pole, or the NCP for short. If you consider the Earth rotating, then the North Celestial Pole is directly above the point of rotation, and so does not turn. So if we think about the stars here, those closest to Polaris with a short polar distance would trace out a smaller circle than those further from Polaris with a greater polar distance. So let us consider how that would look from Earth. Here you can see a star trail photograph showing the circular trails being formed by a moving star. Polaris is in the middle, not moving, while the other stars A, B and C would rotate around. Now star A is different to the other two stars. Star A doesn't, at any point in its rotation, drop below the horizon. We would therefore say that this star is circumpolar at this location because it doesn't drop below the horizon. So what makes a star circumpolar? Well, you can probably see the larger the circle, the more likely it is to drop below the horizon. And the larger circle, the further away from Polaris the star is located. And the distance between a star and Polaris is called the polar distance. As you can see, star A has a much smaller polar distance than star C. So what rule can we come up with? Well, if we think about the altitude of Polaris, if the polar distance is greater than the altitude, then the star would dip below the horizon. And we know that the altitude of Polaris is the same as the latitude of the observer. So there's our rule. If the polar distance is less than the latitude of the observer, then a star will be circumpolar. And if the polar distance is greater than the latitude, then the star will dip below the horizon and therefore not be circumpolar. Sometimes we only get given information about the declination of a star, so it's important to be able to use the equation that the polar distance equals 90 minus the declination. So modifying our rules a little, a star is circumpolar if 90 degrees minus the declination is less than the latitude. Or alternatively, it's not circumpolar if 90 minus the declination is more than the latitude. So let's have a look at a question linked to this. The star Thuban has a declination of plus 64 degrees. Will it be circumpolar when viewed from Ipswich, which has a latitude of 52 degrees north? Well, firstly, we need to work out 90 degrees minus the declination. So 90 minus 64 gives us 26. and then we need to think about what this means. So 26 degrees is less than the latitude of 52. So we can conclude that it will be circumpolar because 90 minus declination is less than the latitude. So now you're confident at working with circumpolar stars, have a go at our key skills questions.